So just as we can use the law of conservation of matter to predict what the coefficients are supposed to be, we can also predict what the products are going to be. It would be nice, wouldn't it, before you put two reactants together to know what the results are going to be, what the products are going to be? We're going to learn 5 patterns, and you saw these back in 8th grade. All right, the first pattern that we're going to learn are the synthesis reactions, which means that we're going to either put two different elements together to form a compound, or, which we didn't talk about in 8th grade, we may put two small molecules together to form one larger molecule. For example, I might tell you that we're going to combine zinc with fluorine and ask you to write the balanced equation for this reaction. Well, it's not really that bad. We can handle this. You say zinc as an element is just going to be Zn. Fluorine is one of the 7 diatomics, so it's going to be F2. We're putting two elements together to form a compound, so zinc has a charge of +2. Fluorine has a charge of -1, so when we crisscross, zinc fluoride will be ZnF2. Now, we haven't balanced it. 1 atom of zinc, 1 atom of zinc, that's balanced. 2 atoms of fluorine, 2 atoms of fluorine. Hey, it's balanced as written. That's convenient. Let's try another one. Let's try potassium plus oxygen. And you say, potassium is an element that's just K. Oxygen is another one of those wretched evil diatomics which will cause you lots of trouble. So that's O2. We're putting two elements together to form a compound. Potassium has a charge of +1. Oxygen has a charge of -2, so when we crisscross, potassium oxide is going to be K2O. That tells us what the reactants and the products will be, but it doesn't give us the amounts. 1 atom of potassium, 2 atoms of potassium. Well, if I wind up with 2, I must have started with 2. 2 atoms of oxygen, 1 atom of oxygen. Uh-oh. If I wind up with 1 atom of oxygen, I can't reduce this to 1 atom of oxygen. I'm going to have to increase this by doubling the whole thing. Now I've got 2 atoms of oxygen and 2 atoms of oxygen. Unfortunately, I now have 4 atoms of potassium, and I had only 2 over here, so I'm going to have to change that to 4. And there's my balanced chemical equation. So that's not too bad. That's just a matter of remembering your common charges and putting those together. But what about when we're putting a couple of small molecules together to form a larger one? There are 3 situations that I'm going to expect you to be able to handle. The first of those is when we have a non-metal oxide and we react it with water. Let's try spelling that right, shall we? Okay, a non-metal oxide plus water is going to give us an acid. Okay, for example, suppose that we have the non-metal carbon, and let's look at its oxide, carbon dioxide. And we're going to react that with water. Okay? You're going to have to think, okay, if this is going to form an acid, acids all begin with hydrogen, so the hydrogen's going to be the beginning of the formula. But what's going to be the end of the formula? Well, what polyatomic ion do I get if I add this oxygen over here? I would have CO3 minus 2, which is carbonate. So hydrogen carbonate, also known as carbonic acid. Okay, this one you kind of have to know what the common acids are so that you have some idea how it's going to turn out. So going back and looking over those common acids again will be a very helpful thing. All right, another situation you may run into is if we have a metal oxide and we react that with water. We'll get a metal hydroxide, which is a base, the opposite of an acid. So to look at an example there, let's say that the metal oxide we have is magnesium oxide. Why not? And we're going to react that with water. We're going to get a metal hydroxide. Our metal is magnesium. Hydroxide is OH with a charge of -1. The magnesium has a charge of +2. So when we crisscross, we're going to have 2 hydroxides. And so there's the magnesium hydroxide that we would wind up with. So this might be in a situation like fireworks. At Disney World, they have fireworks every evening out over the lake, and you can imagine all the ash, all the metal oxide that falls down into that lake and reacts with the water, and it's producing a base, which, while it's the opposite of an acid, is still corrosive. It'll burn the living kapock out of you. And you may notice that they are very, very careful to make sure you don't touch that water. I imagine they put a lot of effort into neutralizing that water before they let it return to the watershed. All right, the third situation where we've got a small molecule plus a small molecule giving us a large molecule is going to be reacting a metal oxide with a non-metal oxide. In that case, what we're going to get is a salt, an ionic compound that includes a polyatomic ion. So this will be another of those times when you'll be very, very happy that you learned those polyatomic ions. So let's say that we're going to react our metal oxide, magnesium oxide, with our non-metal oxide, our carbon dioxide. We're going to get a salt, which is a metal plus a non-metal. Well, the only metal we've got is magnesium. What polyatomic ion do we get when we put this oxygen with that? Well, we're going to get carbonate again, CO3 with a -2 charge. Well, magnesium has a +2 charge, carbonate has a -2 charge, so that's our formula. Now, we should go back and be sure we're balanced. 1 magnesium, 1 magnesium, 1, 2, 3 oxygens, 3 oxygens, 1 carbon, 1 carbon. So that was pretty painless, right? Okay, just be sure that you go back and balance all these, because if they're not balanced, they're wrong.